All right, guys, we are going to start with chapter 3, section 11, number 48, and we're going to start with part A, which is asking us to graph the curve, which is represented by this equation right here. And this equation is representing the St. Louis arch. So if we think about an arch, we're thinking of an upside down parabola. That's the shape our graph should follow. So the first step to find this graph, we know the general shape. We are going to find the intercepts for it. So if you guys are comfortable, you guys can go ahead and work on finding the intercepts. To find the intercepts, you're going to set x and y equal to 0. Okay? So we are going to start with letting y be equal to 0. So we have y equal 0, right, like that. We're going to take our original equation, which is this, and we're going to change this y here to 0. With y equal to 0, we're going to now solve for x. So we're going to bring the 211 to the left-hand side and divide over that negative at the same time to get everything back to positive here. 0.0329. Okay, now that we have this, we can divide over the 20.96, which gives us 10.09, equal to the cosine hyperbolic. Now we have to get rid of that cosine hyperbolic function on the right-hand side. To do this, we're going to use the cosine hyperbolic inverse function that can be found in your calculator. If you have a TI-84, you can go to the second 0, which brings you to your catalog, scroll down to the C's, find the cosine hyperbolic function, and you should end up with about that number equal to 0.03291765x. The final step here is to divide over the 0.03 number to get x all by itself, which means we are done solving for the x-intercepts. And we have x equal to, now a parabola should have two intercepts, plus or minus 91.2. And we are going to keep these in mind for the graph that we are going to do. Okay, that's the first part of finding the intercepts. The next part, instead of y equals 0, we're going to let x be equal to 0. And we're going to solve the same equation, but this time for y, so that we can find our y-intercepts. So here's our original equation. And we are going to take this x right here, and we are going to do times 0. Now, one thing I would like you guys to keep in mind is this identity. I'm going to type. So this is an identity. You start by the cosine hyperbolic of 0 is equal to 1. And this does follow, cosine hyperbolic and sine hyperbolic do follow most of the same function, most of the same properties as the regular trig cosine and sine functions. So again, we're solving this. Let's come back down here. Minus 20.96 cosine hyperbolic of 0. A number times 0 is 0. And we know from our identity that the cosine hyperbolic of 0 is just 1. 20.96 times 1 is still 29.6. This leaves us with our final answer for the y-intercept. So this leaves us with y equal to 190.53. So y is equal to, fix that, 190.53. Now that we have these intercepts, we can go ahead and get our graph finished. Okay, so here are our intercepts. This is part A continued. So we're still working on our graph here. Coordinate plane. Okay. We have the tip of the arch, which is going to be our y-intercept, and we have our two x-intercepts down here. We know our top one was 190.53. That was our y-intercept. That's going to go this point right here. We also have plus and minus our x-intercepts. So we have 91.2 and negative 91.2. I'm just going to put the positive axis label here. But just keep in mind that the negative one is right here. Okay, now that we have that, we can go ahead and connect it, make it look as arch-like as possible. Okay, something like that. So we have an arch shape, we have our x-intercepts, and we have our y-intercepts. So that finishes up part A. Moving on to part B, we are asked to find the height at the center, right? So the height at the center of the arch. So if we just recall quickly what our graph looked like, this is just going to be a rough sketch of our arch, something like that here. So the center, this is supposed to be symmetric across the y-axis. So the center is at the tip or the maximum point of the arch. We figured out that the maximum was at y equals 190.53, and that is going to be the answer for this part. Now the way to prove this, if you don't want to just use the graph, is by recalling, we'll go ahead and do that over here, recalling that the maximum of a function, so the max of a function is when f prime of x, so when the derivative is equal to 0. So this is how you can find it. So to do this, we are going to find the derivative. Second is when, let me make this a little bit clearer. So max of a function, we are going to set f prime of x equal to 0 and solve. And that's going to give us the x value that will help us find our y value for the max of the function. Okay, so we can go ahead and do that. And we're going to start by finding the derivative. So here we need to find the derivative. Here's our original equation. Now something I want to make clear here, when I am talking about these derivatives, this is what I am calling first, the first term, and in blue, this is what I'm referring to as the second term when I'm about to go into the derivative here. Okay, so we're finding the derivative of our original function, f prime of x. This 21.49, just 0, we're not going to worry about it. Derivative of the first, that's in green, is 0. So we're going to move on to the second part of the chain rule, which says first times derivative of the second, which is in blue. Derivative of cosine hyperbolic is sine hyperbolic. Keep the inside the same here. And multiply by the derivative of the inside, which is 0.0329, which is this right here. So now we can simplify this to help us find our max. We have f prime of x is equal to, when you do that, you should get negative 0.6899 sine hyperbolic 0.03291765x. Okay, we're setting this equal to 0. So we're going to change this to 0, and we're going to solve this. If you divide this over, you're going to have 0. You find the sine hyperbolic inverse. So I'm going to quickly go through these steps. You end up with x equals 0. So when we plug x equals to 0 back into our original functions up here, you end up with what we had in part A, which showed us that our intercept was at 190.53, which is also the height at the center of the graph. So that's how you would do part B. Now for part C, for this approach, we are asked to find at what point the height is 100 meters. So to do this, our approach here, we're going to plug in 100 for y and solve for x. So this is the steps that we're going to use. And again, if you feel comfortable now, go ahead and try it on your own now that you have this little hint here. Okay. So plug in 100 for y and solve for x. Here we go. We have our original equation right here. We're going to take this original equation and we're going to replace 100 right there. And we're going to solve this similar to how we did in part A. So we're going to bring the 211 to the other side, which will make this negative, but because we have this negative in front of the 20, those negatives will cancel out. So I'm going to go ahead and make both sides positive. 20.96 cosine hyperbolic 0.0329. And again, we're solving for x in this case. We're going to divide over the 20.96 and continue to solve. Again, we're going to have to use that cosine hyperbolic inverse function. You can do that in your calculator. Cosine hyperbolic inverse 5.319. You're going to divide over, finish solving the equation, and you should end up with x equal to, and again, we're going to use the plus and minus because we know it intercepts on two sides and it is symmetric. X equals plus or minus, with some rounding, 71.56. So again, you're plugging in that 100 for y, solving for x to get 71.56. That concludes part C. For part D, we're going to use that intercept from C, and we're asked to find the slope. So the steps for finding the slope, here's what our approach is going to be. We're going to have step 1, we're going to find the derivative. Find the derivative. Step 2, plug in the value for x that we're interested in. In this case, we're using x equals 71.56 from part C. And the question is what's telling us we're interested in that point. So it's telling us to find the slope at the point that we found. Okay, so there we have it, step 1 and step 2. And we'll go ahead and get started. We have step 1, find the derivative. I did find the derivative in part B. So we are going to quickly go through this, and I'm going to talk through it for the most part. Here's our original function right here, and to find the derivative, we have that the derivative is equal to, we know this is 0, we have the first times the derivative of the second, so we change the cosine hyperbolic. Oops. 9x, and then we take times the derivative of the inside, and we're left with this, which can be simplified to, when you do this multiplication, you're going to end up with negative 0.6899 sine hyperbolic 0.03291765x. So this is our derivative, and again, we got that in part B as well. And now we're going to go on to step 2 to finish solving this part of the question. And step 2 tells us that we need to plug in the value for x that we're interested in. So we're going to take what we just found in step 1, which was this. So here's our derivative. And now we're going to plug in that x value that we need. So we are going to plug in, and I'm going to do it in red. We are going to have this and times our value for x is 71.56. We're going to have a plus and minus here again. So I'm going to do the positive 71.56. When you do the negative, it should get you the same answer. One's going to have a negative sign, one will have a positive sign. That's fine. You should have a positive and negative slope. And once you solve this, so now you're using regular sine hyperbolic. This again can be done in a TI-84. Second 0 to get to your catalog. Scroll down to the sine hyperbolic. And once you do this, you should be left with negative 0.6899 sine hyperbolic of 2.1468. I'm rounding here. When I did the math In my calculator, I tend not to round, so your answer might be off by just a little if you are rounding. And this, again, sine hyperbolic done in your calculator, gives us a slope equal to plus or minus 3.6, 3.5, 3.6, depending on how you're rounded. So there you have it. That's part D. Find the derivative and then plug in the value of x that you're interested in. Again, sine hyperbolic, cosine hyperbolic can be found in your calculator, and that wraps up question number 4.